afternoon all. I hope my voice is audible. Let me know whether my voice is audible. I didn't get any reply whether my voice is audible to all. Shall we start the session? Good afternoon. Shall we start the session? Okay, fine. And now I'm going to share the screen. I'll share question and answer too. Yeah, all of you had your lunch? Okay, fine. Audible. Okay, fine. All of you had your lunch? Okay. I'll share the screen. Just look at the question and later we'll discuss the answer. What would be the electron dot structure of carbon dioxide, which has the formula CO2? We all know that the atomic number of carbon is 6 and the atomic number of oxygen is 8. So, when you look at the electronic configuration, carbon is 2, 4, that is carbon has 4 valence electron. Carbon has 4 valence electron, 4 electron in outermost orbit. In the same way, oxygen, whose atomic number is 8, and it will be written as 2, 6, that is outermost orbit has 6 electrons. Now what happens? Oxygen require 2 electrons to reach the octet structure. Carbon require 4 electrons to reach octet structure, right? So oxygen, one of the side of carbon, shares 2 electrons. You can observe the diagram. Oxygen shares 2 electrons of the carbon, so that now what will be the number of electrons of oxygen? It will be 8, okay, by sharing 2 electrons with carbon. In the same way, the carbon shares 2 electrons with other oxygen atom. And now look at carbon in the center. Carbon sharing 2 electrons of one oxygen atom and 2 electrons of another oxygen atom, so that the carbon reaches 8. So this is about dot structures. This is very important for your board exam. You want to write the valence electrons which represent outermost orbit electrons and try to make it octet structure by sharing the electrons. So how many electrons has been shared with carbon and oxygen? It is 2. Hence it forms double bond. The C double bond O, C double bond O and C double bond O. So both the sides it forms double bond. This is how the oxygen with atomic number 8, the carbon with atomic number 6 share the electron which forms covalent bond. The bond formed here is covalent bond. Okay, hope everybody understood the question. Okay, screen is not visible. The screen is not visible. Okay, what about Gayatri? Can you able to see the question and also the structure of carbon dioxide? Nobody had a view on question? Anybody had the screen on your mobile? Anybody? Okay. If it is not shared, no, I can't explain it without the screen, right? I'll just rectify this within 5 minutes. Okay, I'll just rectify it. Let me see whether it could possible or not. Okay, just wait for 5 minutes. I just changed the settings. funny surprise toys. Thanks for your visit and thanks for your thumbs up. Thank you so much. Okay, now all of you can hear me. Okay, now visible and audible, Revati. Okay, now I'll check out. I'll share the screen for all of you. Okay, now it's visible. Okay, fine. I'll repeat the same concept because previously it was not having clear visual, only audible, right? I'll repeat same concept once again. Just have a look on that. Okay. Before writing any dot structure, we are supposed to know the atomic number. Now look at A shell has 2 electrons, L shell has 6 electrons. So outermost orbit has 6 electrons in oxygen. And in the carbon 2, 4. Outermost orbit has 4 valence electrons. Oxygen has 6, carbon has 4. Now, carbon require 4 electrons to attain octet structure. Oxygen require 2 electrons to reach octet structure. Now, look at the center diagram. Carbon, count the number of electrons of carbon, 4 valence electrons. And the same way, oxygen has 6. Now, you count the number of dot and X around the oxygen, it is 6. Okay. Now, 6 oxygen electron will attain octet structure by sharing 2 electrons with the carbon. So that, now look at the circle around the oxygen. How many electrons are there? You count how many around the circle of oxygen. It is 8. Now oxygen attained the octet structure. But carbon, it has now 6. It required 2 more. So it combines with another oxygen atom and it shares 2 electrons. Now look at once again oxygen. How many electrons are there around the oxygen? It is 8. Okay. Now carbon. Now look at the circle. A circle. Circle around the carbon is 8 electrons. So that all will attain octet structure. Now, how many electrons been shared with oxygen and carbon? As they share 2 electrons, double bond is formed. Now, this is the dot structure you are supposed to practice for board exam. This is very important for your board exam. Okay? Okay. Okay, it is cleared with the dot structure. Okay, if it is cleared, we'll move on to the next image. Okay, in the next image, there will be 8 sulfur atoms. Okay, and each sulfur atom has 6 valence electron. Each sulfur atom has 6 valence electron. It has to share 2 electrons with other element. So, S8, that is 8 atoms of sulfur, they share 2 electrons and they form a bond. Okay, this it will be clearly visible by the image. You just have an image. Now look at sulfur atom. How many electrons are there? There are 6 electrons. And sulfur shares 1 electron from sulfur and the other electron from another sulfur atom. So that the sulfur shares 2 electrons with 2 sulfur atoms. And next, the sulfur already shared 1 electron with 1 sulfur atom and it shares another sulfur atom with 1 electron. Now you look at the diagram. First sulfur shares 2 electron and later each sulfur atom shares 1 electron. Finally, the last sulfur atom shares 2 electron. Okay, now how to write the sulfur atom in a wave shape? Below the triangle shape, take another 3 sulfur atoms. Now in the first row, 5 sulfur atoms. In the second row, 3 sulfur atoms. Okay. Now first sulfur atom give 2 bonds, 2 dotted lines, and rest of the sulfur atom has single bond. Finally, the last sulfur atom 2 lines. This is how the dot structure of S site. I think now all of you cleared with how to write S8, right? Each sulfur you should keep 6 dots. The corner sulfur will have 2 lines and the center sulfur will have single line. Okay, so that all the sulfur will have retained octane structure. Okay, only few people having the problem with the audio and remaining they can hear clearly and they were typing as cleared. Okay, few people they have good network and they can able to see the screen and also audible. The rest few they have the problem. Okay, let me see for a few more minutes. Okay. Okay, I should explain once again. Okay, Kirti, I'll share the screen. You just have a look. How many required to reach octet structure, they require 2 electrons. So, they share the electron with other sulfur atom. The first sulfur atom shares the 2 electron from 2 sulfur atom. And the next sulfur shares 1 electron with other sulfur and 1 electron with other sulfur, and finally with the last sulfur atom. Finally, the last sulfur atom will have 2 lines, and in the center they have single line. Okay. Now, how many sulfur atoms are there? There are 8. So, this is the dot structure of S8. Now, you can count electrons on each and every sulfur atom. It is 6, right? And it shares with other sulfur to reach octet structure. Okay? Okay, at least now cleared with the S8 dot structure. All of you cleared? Okay, if it is clear, we'll move on to the next question. Okay, and this, it will be easy when you practice. It is not theory, completely theory. You want to practice, then only you can have an idea. Only after practice you will get the idea. Okay, by theoretically you can't understand the concept. If you write the structure, then you will get idea. Okay. Okay, we'll move on to the next question. Now, what are isomers? Isomers are the compounds which have same different structures. They have same molecular formula but different structures, and such compounds are called isomers. Okay. Now, how to write different isomers of pentane? Now, how you can write pentane in different way? Okay, by isomerism, having same molecular formula but different structures, that is known as isomerism, right? By that way we can write the different forms of pentane. Okay, let me see how the pentane can be written. Look at the first one. If it is written in this simple way and it is named as N-pentane, carbon will be 5, hydrogen will be 12. So, this is called N-pentane. Now, put 3 carbon in a long. Put carbon 3 in one line, and the center carbon shares bond with other 2 carbon atoms, so that it can form plus symbol. Now you just have a look on carbon. The carbon, it looks like a plus. Okay. And this arrangement is known as neopentane or 2,2-dimethyl propane. The other name is 2,2-dimethyl propane, or even you can name it as neopentane. Neopentane means there will be 5 carbon, but the second carbon will shares 2-methyl group. The second carbon shares 2-methyl group. Okay, hence it is called neopentane. Okay, here 4 carbons are written and the second carbon will share the methyl group. Hence it is called isopentane. Iso means second number. Second number shares the methyl group and the total number of carbon is 5. Hence the name is isopentane. Isopentane. Now all these 3 compounds are the pentanes but different structures. Hence it is called isomers. House of Creativity. Hi sister. Thanks for your visit. Thanks for your thumbs up. Thank you. Thank you for your comment. Thanks a lot for your visit. Okay, all of you cleared with the isomers? All of you clear with the side? Okay, if it is cleared, see how to write different isomers. First you write a long chain of carbon, that will be N-pentane, N-butane, N-hexane, something like that. If you add one methyl group for the second carbon atom, then you can mention it as isopentane, isohexane, isoheptane, isooctane if it is attached to the second number. Okay. If it is given 2 times for the second carbon, then you can name it as neopentane. Okay. Clear? Okay, maybe poor network, but I don't have any problem. I'll go with the next question. Okay, we'll move on to the next question. Okay. What are the 2 properties of carbon which lead to the yield by catenation and tetravalency? The 2 properties supporting to what will be the formula and electron dot structure of cyclopentane? Now you all know how to write the structure of cyclopentane. Okay. This is the cyclopentane structure. If you write dots instead of bonds, then it is called dot structure. Okay. Now, making the carbon complete with 1 octet structure, 8 electrons for each carbon, then it is also called as dot structure. Okay. So, You all okay. The dot structure of cyclopentane is cleared. Okay, few having poor network, but I don't have any problem. Okay, I'll discuss 2 more questions and we'll continue tomorrow. Okay, I'll go with another 2 questions and we'll continue tomorrow. Okay, all of you? Okay, we'll go with another 2 questions. The next 4th question. Rajini, you all know how to draw the structure for cyclopentane, right? You write the bond, okay? Each bond has 2 dots, okay? Wherever you find the bond, you put 2 dots. That will become dot structure. Okay, clear? Okay, we'll move on to the next 4th question. Draw the structures for the following compounds: ethanoic acid, bromopentane, butanon, hexanal. Hexanal is an aldehyde. Okay. Now, let me see the structures. Ethanoic acid, 1-methyl H3, COOH. CH3COOH is ethanoic acid. Bromopentane. Now you write pentane. 1, 2, 3, 4, 5. 5 carbon. At last, instead of CH3, you write CH2. You remove 1 hydrogen and join Br, bromine. That will become bromopentane. That is ketone. Butanon, you write butane and remove 2 hydrogen from any center carbon and then remove 2 hydrogen and add double bond O. You add double bond O, then it become butanon. Hexanal. Hexanal in the sense 6 carbon and the last one will have CHO. CH double bond O. CH double bond O. That will become hexanal. So this is about the structures. Okay.